Well, yeah, all right. All right. Well, hello, everybody. And this is a new episode of Tissue Talks. Now, before I get into it, I just wanted to give a couple of very quick updates. Um, so, um, right now we're going to have Tissue Talks and Rearing Rambles kind of sporadically just because I'm trying to A, move, B, navigate a new schedule, and do a few other things. And right now I'm just going to go live and record this episode. I just upgraded my phone a few hours ago, and right now it's still going through all the processes of setting up, and it's a little stressful. I mean, my old phone is like on its last legs. It can't hold a charge, and it overheats, and it's just I've had it for 5 years. And so today I was like, all right, you know what? We're just gonna upgrade my phone, but it's just, I mean, there are like settings, like I need to turn off the predictive text and the other, the autocorrect. I don't know how to do that. So it's, going to be a stressful 24 hours. But I wanted to take a little while to record Tissue Talks before I go back to adulting and doing my normal tasks. I have to feed some things and clean up after some animals and make activities for next semester. But it's not even 5:30. We got plenty of time. The night's still young. So Tissue Talks is going to be a plant, fungus, and other non-animal thing based podcast, and we're going to get into some interesting things as we go along. Today we're going to kind of do a continuation of our first two episodes of Tissue Talks, and I wanted to let people know, like, later I'm going to go through and like reorganize the Rearing Rambles and Tissue Talks folders and everything. It's something I've been meaning to do, but this podcast is going to be a little bit different than Rearing Rambles in that the criteria for inclusion aren't necessarily as based on success. So generally when I talk about animal rearing, I like to be able to have a species where I've gone through at least 2 generations with it. Okay. So, even though I tried to rear Clidonoptera Letstoni, I'm not going to talk about Clidonoptera because, I came very close to a pairing, but at the end of the day, nothing took. But Tissue Talks is going to be a little bit different, only because the nature of plants is a little bit different. Rearing Rambles is really more about me trying to help people rear better. And I can't ethically do that with species I haven't gotten a few generations through. It just wouldn't be right. Because if I fail to get it through for multiple generations, then it could be something wrong on my end. And so at the very least, I will need to retry. And then I can go one of two ways. I can either do things all over again and see if indeed it was unhealthy stock that I started with and the rearing methods were fine, or B, do different rearing methods to see if they have, different requirements. We will also have a couple of Rearing Rambles podcast episodes that are a little more generalized. So it's not going to be a specific species. So remember how a few months ago I had that Rearing Rambles podcast about, like what I might ask a deity, things like that. We're going to talk really in depth about a few things. We're going to talk about oxidative stress. It's like my favorite thing to rant about. We're going to talk about gut loading, space requirements. We're going to talk about, what's it called? Rearing dreams. We're going to talk about some, just interesting stuff. Now, we also want to have some Tissue Talks episodes, so I might I might have an episode where I talk about sterile culture and things like that. So maybe there'll be some non-species account tissue talks as well. Now, we're going to hopefully have more frequent podcasts, and the goal really is to get people excited about different species and make people not intimidated by things. Rearing Rambles, I really want to be about helping people improve their rearing methods for a lot of different things, mostly inverts, maybe a few reptile and amphibian species, but it's, honestly mostly, going to be invertebrates. A lot of moths, a lot of mantises. You'll see roaches. You'll see all sorts of things. So today we are going to talk about another player in that complex of purple bog orchids. So if you haven't seen the first two episodes, what I talked about alongside one of my favorite native orchid, Pogonia ophioglossoides, Erythusa bulbosa, and Calopogon tuberosus form this complex of bog orchids, and they mimic a rewarding purple aster or some other purple flower that's got kind of a yellow center, and radiating out is a bunch of purple petals. Now, the trick is to mimic that so that pollinators that are going around are landing on your flowers and collecting your pollen, the pollinia, and moving them to the other plants. And it's just deceptive pollination. Now, we talked about Pogonia ophioglossoides in the first two episodes, and that is one of the players in this complex of bog orchids that mimic this rewarding purple flower in the bogs. They are also present in fens. We're going to talk about Calopogon today because Calopogon tuberosus is sort of the jack of all trades of native orchids. So Calopogon is a genus that has, I believe, 3 species. The only ones that are anywhere north of like the Southwest, Florida, Everglades area like that, is Calopogon tuberosus. This orchid ranges all the way up into Canada and is found in a wide range of moist habitats. It doesn't just grow in bogs, it can grow in fens. As long as it's really, really wet, Calopogon can be found. I've found them in the wild before. They can be really abundant in certain areas. Now, it's really generalist not only in the growing environment that you're going to find it in, it's even more so generalist in the tissue culture environment. Now, we have to talk first about some orchid stereotypes, right? The first would be that orchids grow very slowly. Now, it is true that a lot of orchids do grow very slowly. What you have to understand is that lifespan is experienced differently by different organisms. What we deem as slow is probably deemed as normal by the things that are growing slowly. We grow rapidly compared to an oak tree or a cypripedium or something like that. Cypripediums take 5 to 7 years to reach blooming size, which, obviously humans aren't typically sexually mature at 7, but pollutants in the environment are changing that, folks. But anyway, point being, a lot of orchids, especially in the wild, may take decades before they reach blooming size. And orchids are sort of this group of plants that has evolved to take advantage of incredibly narrow, ranges of conditions, partially because the seeds require a fungus in order to germinate and grow. And because of that, the orchid has to not only land in an area, the seed has to land where that fungus is present, the area has to be suitable for the subsequent development of the seedling. And those two things, aren't guaranteed. You can have a ubiquitous fungus that can deal with whatever, and the orchid's more picky than the fungus, And so the orchid seeds may land all over the place and start germinating, but only a fraction of those will survive to a mature plant because, maybe it's too dry, maybe it's too exposed. I don't fucking know. Now, it's okay because the orchids evolved in a time and place where they played the numbers game. Now, orchids are not the best at reproducing. There are plenty of, native orchids in our area that will go season after season after season not producing seed pods because pollination rates are usually low and something comes around, but it's okay because the plant lives for a century or more. So even though, one reproductive event that comes every 8 to 12 months fails, the plant is going to have, 80, 90 or more of these reproductive events over the course of its life. And when you roll the dice enough times, you get the favorable outcome. And that's exactly what they bank on. The same principle applies for the environment around them. Even though there's, one suitable spot for the seedling per square mile, if there are 5,000 square miles, you have a lot of suitable area. And so what seems a little bit kind of maladaptive to us actually makes perfect sense to a plant. You have to remember, this is what I need folks to understand. Human perception is incredibly biased. It is a function of the way we live. For example, folks oftentimes overestimate how much room a captive reptile may need because they imagine this animal wants to walk around all day because that's what we do. We are adapted to being on our feet, walking, moving, always, we're not adapted to a sedentary life. We have this urge and this drive to be active. Now, animals that are prey animals, oftentimes need to conserve their energy and avoid predators. They're not going to want to be darting about. Now, there's nuance there, and I'm not saying keep things in obnoxiously undersized containers. But what I'm saying is, we need to just be careful about how we deem an organism's patterns and behaviors and make sure it's not, influenced by the way our behaviors are. We experience time in a way that reflects our lifespan, and so does every other organism on this planet. And because of that, what seems a little foolish to us, what seems like a waste of time and a waste of whatever, is perfectly natural for a different organism. So Calopogon tuberosus is a widespread and variable orchid. It just requires wetland habitat. I'm pretty sure they've confirmed this with laboratory experiments. They will utilize a wide range of different fungi in the ground and not just a single species. And so the number of suitable areas for Calopogon tuberosus to occur are a little higher than something like Cypripedium macaulay. Okay? Very, very easy concept. The number of suitable spots for an organism is going to limit how many organisms are going to be out there in the landscape. And usually, not every suitable spot is going to be occupied. So, Calopogon tuberosus just needs wet feet. It really doesn't give a damn about the pH of the soil or anything. As long as it gets a ton of sunlight and a ton of water, it does just fine. And, kind of like Pogonia ophioglossaides. We're not going to talk about Erythrus bulbosa because I haven't encountered them. But please, if you're going to go out looking for orchids, don't put rare orchid populations on iNaturalist or social media or anything like that. Okay? I am not a fan of poaching wild plants, especially not wild orchids. And, only exception is seed pods. You can collect seed pods if the goal is to propagate them. Or, like obviously if you're pulling them out of a private property because it's going to get destroyed or something, that's a different matter. Anyway, just don't poach wild orchids. Come on, people. Especially not Calopogon, because they're really easy to produce. Okay. Populations of Calopogon tuberosus in the south, the individuals tend to be relatively large plants. And I'm talking like 3-foot tall, large plants. It's called a grass pink because it has grass-shaped leaves. I mean, it kind of makes sense. They're both monocots. But there are orchids that have much broader leaves. Calopogon tuberosus has very lance-like, very long, narrow leaves. Ugh, excuse me. Give me a sec. I know. I can't work this damn new phone. I hate this. All right. Oh, there we go. I'll deal with that later. I'm really stressed. All right. I'm just checking on my phone. Let me just see. All right, people. Oh, maybe I didn't. Okay. No. You know what? I'm not going to bother with this phone right now. Oh, actually, let me just see. I just upgraded my phone and am still transferring stuff over, and it's stressing me. Okay. I'll deal with this all later. Jesus Christ, this is really irritating. I mean, I had to do it because my old phone is really, really donezo, but whatever. Goddamn. The plant is found all the way through Wisconsin, Minnesota, parts of southern Canada. Those plants are very tiny. I have the cutest Calopogon right now. It's a Wisconsin population, and the corm is tiny. The plant only gets a couple inches tall. I'm hoping it'll bloom next year. Its corm got really big this season. Yeah, I love these plants. Okay. All right, this phone thing is really starting to stress me out. It's gonna be fine. Oh my god. Okay. So I have really bad anxiety. Okay. So Calopogon is one of the players in this group of bog orchids and wetland orchids, as you might more adequately say. They're not bog obligate, and they're actually really easy to work with. So I love to tissue culture things, as I'm sure I've conveyed, and there are species that are really tricky to get to grow well in tissue culture, like eucalyptus, for example. You want to know what happens with eucalyptus in tissue culture? It's like the most frustrating thing, because I just wanted to maintain some culture of eucalyptus, and you like germinate the seeds on the medium, but you have to be careful how long you leave the seedling on the medium, because what happens after a while, after a few weeks, is this callus tissue starts to form, and then you can't get it out of callus. I've tried all sorts of things. I've tried, BAP and to I forget which auxin I used, but it was at a high BAP, a low auxin ratio, because remember, when you're working with the dicot, you have to have the ratio. When you're working with the monocot, you don't need both to get them to do something. You just need one. So, basically in tissue culture, the there are two major compounds, hormones involved in determining growth. So cytokinins tend to pump the gas pedal on growth, whereas gibberellins tend to pump the brake pedal. Auxins are usually inductive of roots. So you want a little bit of auxin to get the root to grow. They don't always need it. Like cypripediums and most orchids don't need an auxin to roots. But in some orchids, a little bit of cytokinin added to the medium speeds up germination. It doesn't for Calopogon, and we're going to get there. This is actually going to be a really weird species to talk about. But anyway, where was I going with that? Yeah. Yeah, I need to I might start scripting these, because I need to keep a train of thought, and I'm just thinking, how can I make this better? But anyway, there are species that can be very tricky to tissue culture. Now, monocots don't need a ratio of auxin to cytokinin to do something, but dicots do. So with dicots, typically, there are some exceptions. Typically, you take a 1-to-1 ratio of auxin to cytokinin if you want it to callus indefinitely, okay? And a callus tissue culture is achievable, but as far as I know, it can cause problems long term. I've also seen things like spontaneously callus, such as eucalyptus and willow, but it's hard to get them out of callus sometimes. But for things that you can get out of callus, what you'll oftentimes want to do is first have like a 2-to-1 or 3-to-1 ratio of cytokinin to auxin to get shoots, and then you reverse the ratio so that you can get roots afterwards. And in monocots, typically you can just speed up growth a little bit with the cytokinin, and you're good to go. Calopogon tuberosus doesn't really give two fucks about very much in its tissue culture environment. Okay? They will grow on basically any orchid germination medium. In fact, they seem to grow most rapidly when you don't add extra stuff to the medium. So you don't add potato pulp, you don't add coconut water, you don't add banana, you don't add any of that. You just use the straight up chemical mix. And I say that colloquially, I'm aware everything is made of chemicals, but you just put the, fancy defined shit together, and that seems to be the best for them. And they don't care if they're in the dark or the light. That's another weird thing. There's, a group of orchids that requires light to germinate, and there are orchids that require total darkness to germinate. These guys don't care. It does not matter to them. Okay? Now, they do grow a lot more rapidly under a light, but they will still develop in the dark. Okay? They do develop rapidly. So, let's walk through it, shall we? I'm also just practicing being a little slow when I speak so that it's a little bit less overwhelming for my audience, because I sometimes have a tendency to speak really quickly. Okay? And I'm sorry about that. I'm trying here, okay? Yeah. Calopogon tuberosus seeds can be bleached for 20 minutes. So, as with all mature orchid seeds, what you do is you get a little bit of clean water, put it in a glass vial with some seeds, you swirl it around, you apply vacuum pressure to make the seeds sink, right? Once the seeds have sunk, you're going to want to bleach them. Typically, you use an 8 to 10% bleach solution, just depending on how concentrated. You basically want to aim for about 0.75 to maybe, 0.075, I believe, to 0.01 or something percent hypochlorite. Let me just double check that. Sorry, you want about a 1% sodium hypochlorite solution, which is going to be roughly 8 to 12% bleach, just depending on how. Because some bleaches, it's like 8% hypochlorite. Some bleaches, like 12% hypochlorite and things like that. I'll oftentimes use I'll use pool shock. I don't know why I'm admitting to this, but yeah, because you can get a gallon of pool shock for the same price as a gallon of bleach, but it's like twice as concentrated. You just get more hypochlorite. And so I will opt usually for the sodium, or for the hypochlorite, or for the pool shock, because it's just more concentrated to begin with. I go through a lot of bleach during the rearing season. I'm sorry. And then when I do tissue culture, I go through so much bleach. Like, I could single-handedly keep the bleach market alive. No, I'm just kidding about that, but I go through a lot of bleach. It's my favorite chemical to clean with. Okay. When I clean the bathrooms, I fill a bunch of bleach in the toilet tank so that when you're flushing the toilet a couple more times, you have bleach coming out. Bleach is very helpful, especially because it rinses cleanly. And that's important for plant tissue culture, okay? Bleach rinses cleanly, so there's no fucking residue left. And you don't want the residue from the sterilizing agent on your culture medium. Come on. So the fact that bleach rinses cleanly is really, really good. It also has the effect of denaturing dormancy compounds, and it's, effective against most contaminants, if not all. I'm sure there are some random things that can survive a bleaching if they're in like a cyst form or whatever, a spore. But typically, bleach just destroys shit, It's bleach. I love bleach. Yeah. Good stuff. So you take your seeds, you get the 10% bleach solution, you soak them in the 10% bleach solution. What I typically do is I put a little bit of tween in the bleach solution. I put the seeds in a little vial. I put the bleach in, I cap it, and then I'll put it in the hood, I'll sterilize that bleach vial. Every, minute and a half, 2 minutes, I'll just give it a swirl or a shake or something, just to make sure that things aren't, staying stacked on top of each other, because that might hinder complete sterilization. You want to surface sterilize these thoroughly, obviously. Then you have a piece of coffee filter over a jar. In the hood, it's all pre-sterilized. You autoclaved it, and that's easy enough to do. I typically take a coffee filter, fold it up, put it in a mason jar, put the cap on the mason jar, autoclave, and then what you can do is you can open it up in the hood after you've surface sterilized it. You can drape the you get rid of the metal ring, the metal, the plate part, like a mason jar has the ring and the main lid. You get rid of the main lid, and then you use the ring to hold that coffee filter in place, and then you can pour your stuff through and pour water through a couple of times. The water's sterilized, so it's all sterile. It's in the hood. You're good to go. So you sterilize this 20 minutes, and then you rinse them, and then I put them on the P723 medium. That's available at Phytotech. I know the formulation, so I just make stock solutions, because I can go through a lot of it, and saving money is always good. Okay. But it is fun to tissue culture these things. I go ahead and I put them on the medium. I pour out the plates. We'll talk about pouring out plates in a different episode. We don't, but I've pre-poured the P723. I spread the seeds on, cap them, and whatnot. Put them under lights. Germination takes about 11 to 15 days. It's very quick. Within about 3 weeks, you need to, reflask them. And so, or replate them, I should say. So I replate them to P668 in jars. Let me try and remember. I believe it's 1 protocorm per 10 milliliters of medium. So if I have 100 milliliters of medium in a jar, I put 10 protocorms on. The protocorms grow very rapidly, and you want to move them when they're still pretty small. They have these this cute little dimple that forms at the top where the leaf starts to come out, and it's a very rapid process. The roots will start getting tangled, so you really want to get them in a new setup very, very rapidly. Then what's going to happen is the seedlings are going to continue to develop. They're going to photosynthesize because I put them under the light. And what's going to happen over the course of another 6 months is this corm is going to grow, and it's just going to keep getting bigger and bigger. It's going to grow to about the size of a pea before it's done. And at that point, it will go dormant. When it does, you can just take those corms out of tissue culture, rinse them, put them in some wet sphagnum moss in the fridge for several months, and then you can plant them out in bogs. Calopogon tuberosus is very, very easy to tissue culture. I believe they take 3 or 4 years after that to bloom. However, I've heard of them taking as few as 2 years, probably in the deep south where there's a lot more sunlight and, it's a longer growing season. I don't think we're going to ever see that. Well, maybe with climate change, you never know. But certainly not my little Wisconsin population. So what I should alert you of is that while that is the method I use, people have had them germinate and grow on a wide range of other media and in the dark. So you don't need to have them on, my typical P723, then P668 under the light regime. You can if you want. I'm sure there are cardboard orchid sowers out there. I'm sure they'd respond well to cardboard orchid seed sowing. I don't know. So that has been my my spiel on Calopogon tuberosus. I don't have much else to say. However, what I'll do, I think, is I'll take a few more minutes and then we'll end the stream. And then I will decide. I have an idea for next Ring Rambles. And I think that we'll have Ring Rambles tomorrow or Tuesday. But let me get back to some of my other things that I was doing. But first, just a quick. I just realized I was planning to try growing Calopogon tuberosus in April because the timing. It's about 6 months for Calopogon tuberosus to be deflasked from sowing to deflasking. 6 or 7 months. So if I start the seeds in November, December, January, February, March, April, May, June or July is when those things come out of tissue culture, and then it just fucks up their cycle. So this coming year, I'm going to sow my seeds in April because the timing will work out better. I can deflask in like November-ish, and then they can, just sit in the fridge until April, and that will work. I want to test insect proteins in orchid germination medium, and I might use Calopogon tuberosus for that. The only downside to Calopogon tuberosus is it seems seeds don't last all that long. Okay, so thank you for tuning in, or if you're watching this in the future, thank you for watching. This has been Tissue Talks. This is episode 3. Have a good night. Okay.